On the Powershell team. Been working on the team for a while. Also the author of the Powershell cookbook. So if you're here to learn how to pop boxes, sorry, this is not going to be the right one yet. So I've got a question. Who here is involved in blue teaming, sort of protecting customers, helping them know how to save themselves from you just breaking them? All right. So what we're going to talk today, you've probably heard a lot in the presentations and chats and stuff so far, are ways that PowerShell and the inbox scripting stuff in Windows is being used to let people escalate privileges and everything else. So what we're going to talk about today are ways that you can help customers detect themselves much more readily and really have a better control on their environment. Now, the one thing that I think is really good to start with is just talking about security boundaries. Now, it seems like a kind of a ridiculous thing to say at DerbyCon, but the big thing that when we start talking about when everyone is running Mimikatz and stuff in memory, ultimately they're an administrator on the machine, and that's going to compromise any operating system that's out there. That's just the way that operating systems work. Now you say, Lee, why did you start with a little word about security boundaries? The execution policy. So when you start thinking about PowerShell and security, what most people start talking about is the PowerShell execution policy and how they bypassed it. That is not a security boundary by any means. The execution policy, has anybody familiar with that term? Malware bypassing execution policy? Yes. So the execution policy, the way to think about that is like chmod on Unix, right? If you're an attacker, you're not bypassing anything by changing the executable bit on a file. You're not like super lead or anything. So that's what the execution policy is essentially a chmod on Windows that gives you more control over, hey, when I run these scripts, do I require that they're signed or anything else? So when here's the first token of instant cred. When you start talking about PowerShell in the wild and with other researchers, don't be so proud of bypassing the execution policy, because PowerShell went and actually made command line parameters to do it, so you're not kind of breaching anything there. So there's a lot of different ways you can have fun, and that's not the one you should be proud of. Now, the other thing that I find when we start talking about PowerShell security is you've got a lot of customers and people who you're in an engagement with, and you're like, look what I just did. I popped your machine with some PowerShell, I got Mimikatz running, and their natural reaction is to start running after the very end game, right? They're running after the tools and the techniques, but they're maybe not mature enough at these bottom levels. So I start to think about it like the Maslow's hierarchy of security controls. Maslow has got his hierarchy of needs, right? So you need to have food and water and all that kind of stuff. Security controls are the same way. So if you're at a customer and they don't have AV, well, they're not protecting themselves even from malware that's known to the entire industry. If they don't have any sort of application whitelisting, then they're not protecting themselves from any random C++ thing dropped on disk. Nobody ever talks about protecting themselves from C++ attacks, but for some reason they think that it's a good thing to start talking about protecting themselves from PowerShell attacks or whatever else. And that, when you start talking about protecting yourself from PowerShell attacks, you're really at the top of the hierarchy there, especially if your concern is, hey, I did this all in memory, forensically clean. If the customer has no capability of doing any sort of memory analysis or disk analysis, then they're really just grasping for straws, and they're just going to get popped 2 minutes later with somebody who just changes their techniques by one little bit. So this is a good way, when you're starting to talk in an engagement with somebody and they're trying to react to something that you've done, this is a great way to start helping them understand what are good, reasonable ways to start protecting from these attacks. Now, we talked about security boundaries. The one place that PowerShell is frequently on an attack surface is the thing built into PowerShell called GIA. Has anybody heard of the just enough administration stuff in PowerShell? Sweet, a couple people. So it's just enough administration is the ability to set up a PowerShell remote endpoint. So when somebody connects up to that endpoint, then all they get are the commands that you want them to run. So you don't have to have administrators running around your whole domain doing everything that an administrator can do. You can say, when you connect up to this machine, you're only allowed to do the following commands.
Guys, we have a lot of people that are trying to get back in. Everyone has like 2 seats between them. You guys please move in so that people move this way and you guys move this way. Okay? There's a lot of people that want to see what he's doing here, so we want to make sure they have a spot to sit. Thank you very much.
Securita has spoken. Parting of the seas. Yeah, good job. All right, so we've got PowerShell sometimes on an attack surface. So when somebody is writing a PowerShell constrained endpoint that's preventing people from running just arbitrary stuff in their domain or on that machine through PowerShell remoting, what you've got here is they'll end up writing wrapper functions in PowerShell. So here's an example of somebody who says, when somebody connects up to this run space, this endpoint, I only want to let them run get process if they're looking for the PowerShell process. You might imagine a situation like that. But if you look on line 10, there's an invoke expression. There's a common misunderstanding that when you're creating dynamic PowerShell, especially around command invocation, that you need to use invoke expression. And I think it comes from Perl and other things that have like the system command. That's generally the way you do it. But this, PowerShell, like any other language, has a capability to run arbitrary code. And so with this, you've got the same thing that you get with SQL injection or command injection or cross-site scripting. So here what the person has actually done is, if the user's input matches the text PowerShell, then I just add it to the get process command and I run whatever I want. Now if the attacker had actually said PowerShell semicolon, format C drive, well then you're owned, right? So there's a great example of command injection that you can help them prevent and protect themselves from. Or if you see this during an audit, this is a way that you can get in. So you really never need to use invoke expression in PowerShell. If you do it on an attack surface, you're usually going to be owned somehow. So the first example that I was showing was trying to pass the user's input to a variable name as a parameter. So you see in line 2, I can just run a PowerShell command, right? I can use the get ACL commandlet to get an ACL on a file. But if I didn't know the parameter value beforehand, I can send it as a variable just to the get ACL-path. So if that had a semicolon in it and further stuff, PowerShell is going to do all the work to ensure that that doesn't become part of the command line, it just becomes the command line argument. Another complicated one is if you have hash tables. So if you don't actually know which parameters you want to call beforehand, and this sometimes happens when somebody doesn't know, for example, if they want to use the ID parameter beforehand or the name parameter beforehand, then you can actually just stuff those into a hash table. It's called splatting. And then pass that hash table to the command, and then all those parameters will be resolved when needed. So again, if you don't know the parameters beforehand, you're good. And actually, PowerShell even lets you run a command when you don't know the command name beforehand. So if you don't know, here's an example of you don't know the command name, you don't know the command line parameters, and you don't know the value for those parameters, and you can still do it without any sort of command injection. So if you see somebody using invoke expression for command invocation, this is a great way to prevent it, just like you would with a prepared statement in SQL or something else. Now I think this might be a little bit hard to read, but sometimes there is a legitimate reason for invoke expression. So for example, if you're interacting with another system and a product, for example, and all it takes is a PowerShell encoded script, what we did add in PowerShell version 5 was this system management automation.language.code generation. Because what you're doing when you're doing command creation and injection is you're really generating code. And so you see here in the code generation API, there's things like, if I'm going to be putting it into a block comment, there's an escape block comment content. So there's all these different APIs, and the one that people will need is escape single quoted content. Because one of the things that people try to do is they'll know that they're in one of these situations where I'm passing it to another system and all it takes is PowerShell. And so what they'll do is they'll know that they'll put it in a PowerShell, a single quoted string, and then they know that if the user ends up having single quotes in there, then they'll just replace them with 2 single quotes, and that will save them from any sort of escaping via single quotes. However, PowerShell was raised in the age of Outlook and Word and blogs and all that kind of stuff, where you put a script online and it gets automatically screwed up to be these fancy quotes. So the PowerShell language actually defines a whole set of single quotes that include single backticks and single left-hanging curlies. There's like 4 or 5 of them. So if somebody's only doing single quote escaping, then you can just use the curly versions to escape out of that. So these code generation APIs take care of that stuff for you because they are written by the same people who wrote the language. There's another situation that people sometimes feel the need to run invoke expression on, and that's when you have a data file in PowerShell. So PowerShell has hash tables, and you can put these hash tables in files. And so those hash tables, you see them in, if you have a PowerShell module, the module manifests are really just hash tables in a file. So when you run into a situation of trying to import one of those things, since it looks like the PowerShell language, everybody goes and they import it and they run invoke expression. That's unsafe because there's lots of stuff that can happen in the PowerShell language, and so that's why we've got this ast.safeGetValue. So this will be on the deck that is out. If you're interested, you can look at it later. But this will actually visit the AST. This is the equivalent of people who take a JSON parser and they just run eval in JavaScript versus people who actually write a JSON parser full up. So what we've done with this safeGetValue API is done it as a hash table parser, so you don't have to worry about arbitrary content coming into your process if somebody manages to inject themselves into the file that you've loaded. So those are the situations where you might run into somebody putting PowerShell in an attack surface. Those are some ways that you can attack them and also ways that you can help them prevent the attacks from happening. Now that said, there's been a ton of situations where PowerShell is not actually on the attack surface, right? So PowerShell is being used, somebody pops a box from SQL injection or command injection or something else. Once they've done that, then what they're doing is they're starting to pull in PowerShell running invoke mimicads. Maybe they're doing it in memory, they're doing stagers, all this fun stuff, the fun stuff that we love to watch how creative it is. Now, that situation is just unauthorized system administration. We spent the last 10 years writing PowerShell to be a powerful system administration language. We're not about to start ditching the language and ditching the ability to run .NET because that's what makes it such a fantastic experience on Windows when you're authorized to do it. And so what we've done is spent a lot of time in PowerShell version 5 to make it more security transparent. So a reasonable problem before was people were doing this stuff and there'd be no way to know. So we've spent a lot of time cranking up the logging in a bunch of different ways that makes PowerShell you are never uncertain what's happened with PowerShell in your box when you've installed PowerShell version 5 or Windows 10 and then you've enabled the right things. And we'll go into those right now. Now the first one is pipeline logging. So this has existed since PowerShell version 2. It got a lot better in PowerShell version 3 and version 4. And you can just set a group policy that says, PowerShell, whenever you run any command, just log the command that was run and all the arguments that were passed to it. So what you see here is an example where somebody is using the add type command. So the add type command in PowerShell lets you take a string of C#, compile it in memory, and then run, let's say, any methods from there. Now, what I did here, in the first couple lines, I ran the add type command, and that was now C# code in memory after it was compiled. And the next part you see here is the logging of everything that happened. So you see here that I ran add type dash type definition with a script. So that's a great way to see every command that was run on the system. There's a lot of commands that there's a lot of attacks and a lot of scenarios that don't involve just simple PowerShell commands. And so we also added transcripting and script block logging, which I'll get into in a second. So transcripting also has existed since version 1, and when anybody tries to use it as a security control, until version 5, they ran into challenges. So transcripting is the idea that what would you see if you're looking over somebody's shoulder on a system? You see them typing commands, you see the output coming, and that's a great way to understand what's happened to a machine. So let's give a little demo of that here. So I'm going to start a transcript to an output directory. I've run some commands. And now I stop the transcript. What we did that was kind of fun is that we added that's not just a string that comes back, it's an object. It's got a path. So now we can see this is what happens with over-the-shoulder transcripting. So I can see here a bunch of interesting things. You see here there's a username and a run as user. That's a great thing to do when you've got PowerShell transcripting enabled on a remote system where somebody is logged in and you've got PowerShell does support credential translation. So you can log in as somebody, so I connect up to a machine, and then it elevates to a local admin so that I don't have any danger of domain-wide compromise. So what you would see here in that transcript, that it was being run as, let's say, a local admin, but the user connecting was me. A bunch of information about PowerShell, and then you also have command headers so that you can later process these things and have kind of output command response things. And it looks like you would expect the output of get process, the output of get ACL. Now that's kind of what existed since PowerShell version 1, is the ability to interactively say start and stop transcript. But what we did add in PowerShell version 5 so here's the one that I was talking about before, turning on module logging. I can enable it for all modules. And now every command that PowerShell's run is going to get logged in the event log. Now PowerShell transcription, you can enable this, give it an output directory. And I can include the invocation headers that we saw. So now I've enabled system-wide transcripting. And before, the only way that you could do that was by putting this start transcript command in the PowerShell system-wide profile. And so when that works, so when that works, what you'll see is a transcript start appearing here. Now the cool thing given that that's a system-wide transcript, so we made a mistake in the early versions of PowerShell of adding that transcript support to the PowerShell console host itself. So this blue thing that you see here, this blue console, that's not actually PowerShell. That's a console application hosting the PowerShell engine. So you've got also the PowerShell ISE, right, the integrated scripting environment. That's a Windows application hosting the PowerShell engine. So we made the mistake of adding transcripting to the console host itself, just the native executable. And so what we did, along with moving this to system-wide support, we put it deep into the engine. So without any changes now, the ISE supports transcripting, and it also listens to the automatic system-wide transcripting if you've enabled it. Trying again. Well, the problem is I'm doing this on a real domain join machine, and that'll take forever. And so here's an example of a ignorant transcriber. So I showed you the add type command, where you've got, I told you multiple things can host the PowerShell engine. And so here's an example of me creating a C# class that hosts the PowerShell engine, and it's going to run get process for all processes that have a name that start with S, right, as an example. So this is a C# class that does this. The add type command just compiles that into an exe. So now I have an executable hosting the PowerShell engine, and because this was done deep into the PowerShell engine, it's going to pull up transcripting support as well. I can do it over here. Oh, you know what I know I can do? It'll be much better. Better not get stuck in here. So what I can do here Get rid of all these PowerShell windows. So I've got a PowerShell module here that does all these things without waiting for the group policy updates. So what I can just do is enable PS transcription. So that's now enabled, and I can run the, well, let's show you first that something actually works. All right, finally. So you see we got a system-wide transcript that you get kind of the over-the-shoulder view that was enabled via group policy. But now there's this ignorant transcriber thing. So it did the great useful thing of telling me I have 30 processes that start with the letter S. It came and went away. This person who wrote this thing had no idea that transcription was enabled on the machine. But you get basically the same view since we did this deep in the PowerShell engine. So if you're trying to do any sort of change management control on a machine, this is a great way to say, to know exactly what's happening on your systems. And so this is a virtualized view of what the process would have seen. And you can see here that it was actually done from the API. The command looks different. It doesn't look like a person just typed it. It was an API command. There's even the host application you can see here, and the process ID. So you can see exactly what happened in that process while it was run. Now, that's not much of a security benefit that way. If you're dumping transcripts onto the local machine, then you're probably just going to have somebody who sees that it happens, and they're going to delete all the transcripts. What you would definitely want to have is auditing of any protections you've got, but one great example that you can also set up so Windows, like anything else, supports the ability to create kind of write-only shares. So what I've done here is I've created a PS transcript share. Now this will create a share on a specific machine, and it'll share it out as C:\transcripts. The administrator gets full control, but everything else, you can drop all the permissions. So if you're dumping transcripts to this remote share, and somebody takes over a machine, they can't even see the transcripts that they previously wrote. And then you create the new SMB share here. So you do this on a distributed file server. All these would have a share, and then all your systems in your enterprise or whatever could be all going against this same share. Yes. Yeah, so the question was, tell me if I get it right, that I'm a defender, I've created a transcript share. Who's the owner of the file on that transcript share?
Yeah, before you do something like this right here, you can see those transcripts.
So if you're just doing this to a local machine, they're automatically logged to the current user's documents directory. So that's the default. And so there's always going to be controlled by the ACLs of the directory that you put them into. Right. So you're worried about the attacker reading more sensitive transcripts. So if you're storing those transcripts on the local machine, and the attacker has admin privilege, then they're going to be able to do that. If they don't have admin privilege, then you just make sure that you're logging them to a directory that they don't have permissions to. Now, the question you have is a really good one, and we'll get to it a little bit further of what can I do to protect all of this sensitive data that I'm storing on the machine, and we got some great stuff for that, and I'll show you that in a minute. So that's the ability to, you can now create a remote transcript share that all the machines will dump into, and it will show you everything that happened as though you were looking over the shoulder. But there's some things that you don't see when you're looking over the shoulder. So how many people have seen in presentations like PowerShell -encoded command, dash execution bypass, the kind of the typical PowerShell stager? Anyone familiar with that? Yeah. Now you might wonder, like, Lee, PowerShell, why did you make a parameter specifically for attackers? So this is why. So, yeah, it's the best thing. Now that's an example where even looking over the person's shoulder doesn't really help you out. You know, all you see is this encoded command and you don't know what to do with it. What that encoded command did turn into, though, is a set of PowerShell script blocks and PowerShell invocations. And those script blocks invocations meant something to PowerShell that was, you know, either good or malicious or whatever. But let me show you a bit of the background behind that. So I'm in PowerShell right here. I can type in PowerShell 1+1. I'm giving it a script block. PowerShell runs and dutifully says the answer is 2. That's great. I can do more complicated things like get process-name PowerShell. Now, if you were to be a betting man or a betting woman, you'd probably say, hey, this is just returning text, because you'd expect that coming from things. But when PowerShell sees that you're using these script blocks, it actually does something much smarter. This isn't text. I'm using the getMember commandlet here. Look at all these properties, delicious properties. So this is a deserialized system.diagnostics.process. And given that these are all properties with real like int32s and int64s and stuff, oops, wrong one. I can do things like so that was a numerical sort, that wasn't an alphabetical sort. If this was text and I had some magic awk, sed, grep magic, that would have been alphabetic anyways. This is the core infrastructure that causes encoded command. So you might, for example, send this same syntax to a process that doesn't understand it. So you can see here what PowerShell did is it saw, I was launching a process with a script block. What I'll do is I'll give it an encoded command and an input, and I'll give it input format of XML or output format of text. And now this is, PowerShell understands this and would do all that right object magic. CMD doesn't, so this is why that parameter exists. If you're a blue teamer and you see encoded command used with anything but input format and output format, like in this exact syntax, you've got something happening. This will never have execution bypass. It will never have window style hidden. It will never have no profile. This is the situation that you can just light up if you see something like that. So you've got all these script blocks happening, so this encoded command. One thing that we've added is script block logging. Now I've enabled script block logging, and when you've done this across your systems, PowerShell now has a bunch of new events. So I just ran some simple math, some variable access. I ran an invoke expression of hello world.
Woo!
Yeah. So let me do that again.
All right. Yo.
So what we see here is PowerShell with script block invocation logging enabled. Here's a bunch of commands that it's run. So it ran a 1+1, a prompt. It ran an invoke expression hello world. And I'll run this again. And it will also have evaluated the string hello world. So with this, you have, even if you're running encoded commands, you don't have to worry about what is happening. So let's see what that looks like. So you see here that PowerShell started up, loaded some modules. Here's the prompt that was run. You can imagine an attacker saying, I'm going to be really secret, and I'm going to edit the prompt on the machine and just start PowerShell and kill it, and then all the command invocation happens via the prompt. So that was all logged. And here is the script block that was run from the other console. And so you can see all the script, even the script that was in the PowerShell formatting files, was right there for you to analyze. So any of that stuff, if it's tampered or not, you've got access to it. So there's a simple example of like PowerShell dash command, but let's take a look at a more complicated example. So you see something like this, PowerShell dash command with it's doing a web stager, going off to bit.ly, who knows what is pulling down. So what might be happening here? So you've clearly got some bad stuff happening on your network now. It looks even better if you have more than 640 by 480. Now, what happened? This is some epic shit. So what we can do, so pull out the message parameter, put it into the clipboard. Now let's start analyzing what happened. So you see here I had script block logging enabled. I ran this. Some major boring shit. So then you see here we launched, we loaded the profile here. Now here's where it starts to get suspicious. Here's the invoke expression. And then a module loaded that's on my machine. Now that invoke expression, what you see here is, this actually pulled down this. And this is complicated. This would be a hard thing to reverse. You've got a download string. There's a ton of data here. And then you see we've got some more complicated stuff around, like we have it was actually gzipped compressed stuff in memory. How are we going to start to figure out what's that in? So it takes this big block of data, decompresses it, and then it runs invoke expression on that structure. So you might think that that's pointless. You've now got malware that downloaded gzipped data off of a stager, ran invoke expression on the data structure. But now we can see what actually was done in the invoke expression. That looks kind of complicated. Oh, that's not too complicated. You can see here that the half of the data that was taken down were the text frames of the animation. So with script block logging enabled, you don't have to worry about people doing suspicious stuff that you have no idea what it is, because it's all logged for you. Now there was, you had a question about what do I do when I've got all this amazing logging enabled? One of the fears is like, if an attacker compromises the machine with all this logging enabled, we're going to have some serious danger if they can start looking through all this logged stuff. Maybe there's been credentials, maybe there's been passwords, sensitive shares. And the good news is that we got your back there. So PowerShell version 5 added the CMS message commandlets. So CMS stands for the cryptographic message syntax. So that's a standard thing out there. It's supported in OpenSSL and Windows. It's based on the encryption that people use when they're doing signed emails. So we added the get, protect, and unprotect CMS message commandlets. Now what you can do, if you want, is this is just a regular cert. It has this is the OID for document encryption. So if you've got any system that does certificate issuance, you give it this OID and you've got an appropriate certificate. So this is really boring. You don't want to do it this way. Because what you want to do is the new self-signed certificate commandlet that's in Windows. And I'm just going to give it a document encryption cert as the argument. So now I have a new self-signed certificate. And you can validate that you've got them. Here I have in the local machine I now have this self-signed document encryption certificate. And you can even just use the document encryption cert parameter to figure out which ones you've got. So here's an example of actually how easy it is to encrypt something. I've got some text. Send it to the protect CMS message commandlet. So it's just kind of a regular ASCII armored encrypted using public key crypto text. Now, if you want to check out all the stuff that you can do with one of these things, you've got the recipient info. So the nice thing about this encoding format is that it contains who it's for. So you don't have to worry about, when you're decrypting, actually saying which recipient did I use for the encryption. And then I can just take that same content and run it through unprotect CMS message. So that's using like sweet up full public-private key crypto. Now you might be like, well, here's an example of how you would do it in OpenSSL actually. So the only thing that gets challenging about interop with OpenSSL is that OpenSSL assumes that the only thing using the cryptographic message syntax are literally emails. So when you're doing the back and forth, just a quick example of like taking off the MIME header and just kind of massaging the data itself into the OpenSSL format, but then it encrypts and decrypts just fine. So that sounded like it was useful, but then you might still wonder, how does this at all relate to me and encrypting event logs? What we've added is, let's clear this event log again. What I've done is I've enabled script block logging, but I've also enabled protected event logging. So the magic of public and private key crypto is that the encryption key is different than the decryption key. So you can leave your public key everywhere on all the machines in an entire enterprise, and then PowerShell can encrypt to that certificate. And then when you have your SAM or whatever you have taking these event logs off the box, you can have your private key on that collector machine and then decrypt them all there and not have to worry that a machine-wide compromise is going to disclose sensitive data. So I run a thing. Yeah, popped calc and a blue team. Now disable these things. So one warning that we've done is really great is you get a warning if the certificate that you've left behind contains a private key, because you're not helping yourself at all if you've got the private key in the box and you're encrypting all this stuff. So let's well, I don't know why this isn't working. But when it works, you get great encrypted content everywhere. So what you would see is that the content of all those script blocks are going to be the CMS message format, and then you could just either pipe the output of get win event to unprotect CMS message and it would be automatically decrypted for you, or you could just send the text itself over to other machines and do it that way. Oh, that is very great. Thank you. Yep. That's why. It was so seamless that you didn't even notice. We worked so hard to make it seamless. So this is what's actually in the event log. But to show you how easy it is to convert it to a thing that your systems are already used to when they're ingesting these things. So that's what it looks like when you include the context. You can even get rid of the include context parameter and actually just get the text itself. Oh yeah. So that's CMS message. So you can enable this rich logging in PowerShell and not have to worry at all about that data getting left behind. So thanks for your time. Any questions? Oh yeah. I don't know of any that are, and that's why we've tried to make it as easy as possible to take it out of that format so that they can ingest regular messages. All right, thanks everybody.